All right, so welcome back. Today I am finishing 6-7. Last lecture I did one example. Today's lecture I'm going to do another example. So today's lecture is probably going to be shorter than last time. Once I'm finished with 6-7, I am going to talk about the midterm exam. All right, so 6-7 is first, and then I'm talking about the midterm exam. So under my stat lab, if you go back to my stat lab, what you'll see is you'll see on today's date, you'll see the extra problem that I have there. All right, so you have the extra problem from section 6-7 that I'll be working on today. It's very short, so it's just 2 pages. If you only have to print out the second page, that is the example, if you're following along in that manner. Okay, so what I want to remind you of again is when you click on announcements, all our announcements are there, so make sure you keep reading announcements. The StatCrunch assignment is due on the day of your midterm exam. So remember to bring in your StatCrunch lab number 1, which you should already have done by this week. You shouldn't use the week of your midterm to finish it because you should be studying for your midterm. So make sure that lab 1 is finished this week, because next week you will be needing to study for your midterm. Okay? The questions on that lab 1 should have been, there should have been 6 questions on there. So when you print it out or when you open it up, make sure all those questions are there. Sometimes if you have a different version of Microsoft Word, stuff, you know, what you're looking at isn't all there, so things get moved around. So you want to make sure that all the questions are there that should be there. Okay. So for today's lecture, if you go to homework after today's lecture, I have the lecture questions that will give you credit for watching today's lecture. So when you click on lecture 13, which is our lecture for today, there are only 2 questions. And the 2 questions that I have here correspond to, it's just that one type of problem that we're going to be looking at today. So I want to give you time during the lecture to ask questions. Maybe we can do one of these together. Of course, your numbers will be a little bit different, but I want to be able to talk about this as well. Okay, so there's 2 problems to get credit for today's lecture. All right, so I will take you back to the whiteboard. So on the midterm exam, I will be giving you questions that are very similar to the one we worked on the other day. So let's see if I can find it here. That was the example that we went over the other day. And so I will be giving you questions similar to this. This type of question is a binomial type question. It's from, well, it is a binomial type question. It's a binomial type probability question, right? And so you could solve this using Chapter 5 methods. And the lecture we had the other day, I solved this using Chapter 5 methods, just to show you that yes, we can use Chapter 5 if we used binomial. I think we did 1 minus binomial CDF, and then we entered n, which is 431, p, which is 0.5, and I didn't enter 235, but we entered 234 because that gave us the probabilities out of what we didn't want, and then of course we subtracted from 1 to get the probabilities of what we did want. All right, so that's what I'm referring to when I'm talking about using Chapter 5 methods. All right. So the most efficient way, if all you want is an answer, if your goal is just to get the probability and do this quickly and just get an answer, then using the Chapter 5 methods is the way to go. So I'm just looking at my work here to see what we ended up getting on that one. I think I have the answer at the end, but just curious. I don't know, maybe someone else has it and they can type it out. I remember 0.033 something. I think it was 0.0335. What do you guys think? All right, I have a thumbs up. Yes. Okay, 0.0335. All right, so you have your notes from the other day. Okay, so this is a binomial type problem. So you can use the Chapter 5 method, which is your binomial. It's a binomial type problem. So you can use the methods we used back when we were talking about binomial problems. And we used the formula, the binomial formula. There were also tables, but we also had the calculator, and the calculator was the quickest way to get our answer. So for the phrasing of at least, we used the 1 minus binomial CDF. Okay? So if I do not tell you on the midterm how to solve these type of problems, then use your calculator. Use the methods from when we talked about the binomial distribution, and you're okay to use the calculator. However, if I tell you to solve this type of problem using the normal distribution, so if I tell you to approximate the binomial using the normal, then you have to use the methods of section 6-7. If you use the methods from Chapter 5, then what's going to happen is you're not going to get credit for that, okay? So if I ask you to use the normal to approximate the binomial, you have to use the method that I showed you during our last lecture. So that's very important. You don't want to lose points on the midterm just because you didn't follow the instructions. All right, so that's very important. Okay, so I finally found my notes. So that's what we ended up getting. Okay, and then when we actually finished, when we used the other methods, the section 6-7 method, the area we ended up getting was 0.0336. So that right there is our approximation. That 0.0336, that was our approximation. Going through all those steps allowed us to find an approximation using the normal distribution. So we used the normal to approximate the binomial. And it's a good approximation, it was pretty good. All right, so today what I'm doing is I am continuing that. So these are the same requirements we talked about last time. All right, so I'm following the same steps from last time. All right, so the example that I'm looking at looks like this. All right, so that's our new example for today. All right, so I am going to go through the steps. I have all my steps here from the notes that we went over last class meeting. All right, so the very first step, we have to check that first of all, we can continue using the normal to approximate the binomial data. We can even do that. And so what we have to do is we have to check that n times p is greater than or equal to 5. We have to check that n times q is also greater than or equal to 5. We cannot continue if these two conditions are not satisfied. So let me go ahead and write this at the top, that here I'm asking you to use the normal. That means use the normal distribution, use the normal to approximate the binomial. All right, I just got an error message right now, and it says that there is a problem with the program that I'm using. Can you confirm that you can hear me? All right, I might get disconnected, so if I do, just hold on. All right, I just got an error message. It said something. Okay, but I'm still recording, and you guys can hear me. All right, but I'm still logged on. So just in case I get logged off, and just wait for me. I'll log back in. Okay. So we have to make sure that this condition is met. So I'm using the normal here to approximate the binomial. And on the midterm, it will have to tell you that. It will have to say use the normal to approximate the binomial, this binomial problem. It has to say that in order for you to use this method. Okay, so let's go ahead and identify what n is, what p, and I guess we'll also have an x. We'll identify what x is as well. All right, so in this case, we have we're talking about surveys here. Okay, surveys included a request for an email address. All right, so this is just an example from our textbook. So the author was mailed a survey from Viking River Cruises, and the survey included a request for an email address. We're assuming that the survey was sent to 40,000 people, and that for such surveys, the percentage of responses with an email address is 3%. If the true goal of the survey was to acquire bank of at least 1,150 email addresses, find the probability of getting at least 1,150 responses with email addresses. So we have three numbers here. We have 40,000, we have 3%, and we have 1,150. So what do you identify as n? N is always the larger, right? N is always the larger number and has to be the larger number. So out of 40,000, we are selecting at least 1,150. Okay, so then our probability is going to come from that 3%. So if there's a percent given to you, a fraction, that's going to determine your probability. All right, so always turn it into a decimal. 0.03 is your probability, right? From that 3%, you always turn it into a decimal. Okay, now x here, it says at least 1,150. So 1,150, it says at least, so that means no less than 1,150. So no less than 1,150. 1,150 is the smallest number we could have. So it can be anything from 1,150 all the way to 40,000. All right, so I put my ... there. So that's we're looking at that number and everything to the right. There's my arrow there, indicating that I want that number and everything to the right. Okay, so my first step is to verify that n times p is greater than or equal to 5. So go ahead and multiply n times p. So here's n. I'm just circling n. And here's p. Multiply those two and tell me what you get. And that is greater than or equal to 5, right? It's definitely greater than or equal to 5. Okay, so your 12,000 is greater than 5. And then you have to go ahead and check the n times q. Now I didn't give you q, but you know enough to find q on your own. The problem did not give us p, but we know enough to find q. And so remember, q is 1 minus p, so 0.97, right? Okay, so then for n times q, if you multiply those two, you got 38,800. Okay, so that's also greater than 5. Okay, so we can continue because the requirements have been met. N times p and n times q both are greater than or equal to 5. So we can continue. Okay, so now when we go to step 2, step 2 requires that we find the mean and the standard deviation. Now I'm putting these in steps just so that you can match it up to the notes, but you don't actually have to label step 1, step 2, step 3. As long as you just do it in order and it's neat, I'm okay with that. But I'm just putting step 1, step 2 just so you can follow it with the notes from before. So step 2, we had to find the mean and we had to find the standard deviation. Now the mean for binomial type problems, the formula was n times p. The standard deviation for binomial type problems was the square root of n times p times q. Okay, so knowing this, what do you get for the mean? And let me go ahead and tell you where I'm, n times p, so here's n, I'm circling n again, and p, it's the same 1200 from before, right? Okay, so the mean is 1200. All right, so now the standard deviation. So it's going to be the square root of 40,000 times 0.03, which is our p, and then our q is 0.97. So when you multiply that, you want to make sure you take the square root of it. Now you have to be careful of not to round that too early here. So 5 to 6 places is pretty good. But do not say 34.12, for example. So you want to keep as many places as possible. So you got 34.11744. And I see 3 4s there, so I'm just going to keep it to about 6 places. All right, be careful not to round that too early as far as trying to write everything for the standard deviation, all the places after the decimal. But if you stick with 5 or 6, that's pretty safe. If you round your standard deviation, what happens is the z-score that we're computing after this step, it's going to be very different. So just be aware of that. All right, so step 2 was finding the mean and finding the standard deviation, and we have both of those. Okay, so let me change my color here so we can get to the right, to the next step. All right, so step number 3. Step number 3 requires that we identify our x. We have to identify our x. Now here I know we have that x is going to equal 1,000 150 and everything that comes to the right. But you have to start with that the first one. You write x is going to equal 1,150. We're not dealing with the at least 1,150 just yet. We just need a starting point. And that's what your x is. That's going to be our starting point. But we're not shading to the right or shading to the left just yet. We just need to know where we're going to start. Okay, so let me remind you, this is just a side note. When we use the normal distribution to approximate the binomial, we're using a continuous distribution to work with the discrete distribution. Okay, so when I look at 1,150, I have to compare that to where it lies with respect to the mean. The mean was already calculated in step 2. It was 1,200. So x, is that located to the left or to the right? If you look at your distribution here. It's smaller, yes, okay. So it is located here to the left. Okay, so what I am going to do is this strip that you see there, that strip represents my x, the 1,150. So if I were to shade that strip, that would be the probability that x equals 1,150. But in this case, I don't just want 1,150. I want at least 1,150. Okay, so when I look at this, I need to label where that rectangle, where that strip begins and where it ends. I need to be able to label that, and I'm marking those. They're a little bit slanted, so I'm marking that. All right, so that's what step 4 requires that I do. So step 4 requires that I take x minus 0.5 and x plus 0.5. So that means that these are my markers for that strip. So the strip starts at 1,149.5. That's what happens when I subtract 0.5 from x. And that strip ends at 1,150.5. So the strip starts and the strip ends at those two numbers. So I can go ahead and label them down here. I'm going to have to try to see if I can write a little slanted on this. So 1,149.5 and then 1,150.5. Okay, the numbers don't fit there, so I'm trying to slant them. Okay, so at this point, we need to decide what region we're shading. Okay, so that's my step 5, which is the distribution here that I just drew. Step 5 is where you draw your distribution. I had already drawn my distribution, but I have to decide which region I'm shading. And do I include the strip? So what we do is we look at the wording. The wording says, what's the probability of getting at least 1,150? So I know that we're already including 1,150. So notice that I'm trying to shade that strip because I'm already including 1,150. So you need to make sure you shade the strip. But when it says at least, do I shade to the right or to the left? At least. So the least you can have is 1,150. So not only do we get to shade the strip, which includes 1,150, but you have to shade everything to the right. Good. Everything to the right. All right, so that's, hopefully you can see that being colored in, everything to the right. So that is what we're going to have to just find the area underneath the curve. So the hardest thing here is identifying what the markers on that strip are going to be. That, I believe, is the hardest thing on here. All right, so I am trying to change. There we go. I think that's my pen. No, that's my highlighter. Okay. I think that's the pen. Yes, okay. So what I need to do now is, I already have the markers, and again, I said step 4 is probably the harder step, just because you have to figure out what the markers are, where that strip ends and where it begins. And then you have to figure out if the strip is included and whether we shade to the left or to the right. Now, this is not a standard normal distribution. It is not a standard normal distribution because the mean is not 0. So what we're going to have to do is we're going to have to find the line, and I usually put it at the bottom, but I ran out of space here. I usually put my Z right at the bottom. And it still might work. Let me change it. But so now you have to find that horizontal line right at the bottom that represents your Z's. All right, so that's what you're going to see me draw here. It's probably going to cross some of those numbers, but that's okay. All right, so that's my Z. All right, so the mean is going to be 0. The mean is going to be 0. So I have my formula, and that formula says Z equals X minus the mean divided by the standard deviation. So I need to figure out what I'm going to use for X. So remember that everything in the strip is shaded, and then everything to the right is shaded. So where does that shading begin? So that's what you're looking at. Where does that shade, where did it begin? Where did that shading begin? That's what you're going to use for X. And that will always be the question. Where does the shading begin? And that's how you're going to determine X. Okay, so yes, in this case, we have $1,149.5, that is our X, and we are going to subtract the mean from that. So minus 1,200, that's our mean, and we're dividing it by our standard deviation, so remember we're going to write it all out. So 34.11744. So if you leave it to 5 or 6 places after the decimal, that should be fine. Our Z is always rounded to 2 places, right? So if you put that in your calculator, remember that you need parentheses in your numerator. Don't forget those parentheses. Make sure you keep your numerator together. That should give you your Z-score. And it looks like you guys agree on that. So negative 1.48, and you rounded it to 2 places after the decimal. Good. Okay. So once I have a Z-score, now I'm ready to go and look for the area that corresponds to that Z-score. Because what I'm trying to find here is the area underneath the curve, because that is my probability. All right, so go ahead and find your table. You're looking at your Z-score tables. And you are looking up the z-score of negative 1.48. Okay, negative 1.48. So negative 1.48. Here's negative 1.4. Negative 1.40, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so did you guys type this one out? Yes? Okay. So that is the area that we get when we look up a negative 1.48. But is that the area to the right? Or is that the area to the left? So if the table gives you the area, yes, it's always, always, always the area to the left. Always the area to the left. So remember, when you're using these tables, when you look up a z-score, the area you get is always the area to the left. So you have to make an adjustment if you wanted the area to the right. So 0.0694 is what we have. So let's put that where it belongs. So that is this area, 0.0694. And that's not what we want. We want the shaded region. So to get the shaded region, you're going to subtract. So it's going to be 1 minus 0.0694. So the area in the shaded region, 0.9306. Is that what you guys got? Good. So that is the area in the shaded region. All right, so let me change my colors here. So I squeezed everything in. So I just want to make sure you can see what my notation is here. So the probability that x is at least 1,150, so that means at least 1,150. That's what the question asked. The probability that x is at least 1,150, so it could be 1,150 or greater. That is our 0.9306. Now, I went ahead and gave you the answer that I obtained through the normal distribution. So we used the normal distribution to get our answer. Now, is this 0.9306, is this the exact probability or is this an approximation? Yes. What we just did right now, it is only an approximation. That's what it is. Look at the very beginning when I started explaining. At the very beginning here, if you see I'm pointing at it, we can only use the normal to approximate the binomial. So the answer that you see here, it's just an approximation. So when we use the normal to approximate the binomial, it's only an approximation. What I've just done is an application of the normal distribution. Yes, it takes us, it's a lot more work on our side to use the normal to approximate the binomial. It's more work than just using our calculator and using the binomial CDF. But this is very important because this shows you an application. It shows you how the normal distribution can be used. And this is very powerful property of our normal distribution. It can also be used to help us approximate distributions that are not continuous. So the normal distribution was a continuous distribution. It is very helpful to help us approximate a distribution that was discrete, like the binomial. So this is an application of the normal distribution. So I'm not just asking you to do this so that, so you have more work on your hands. It's very important. It's very important to understand that the normal distribution can be used in this manner. So it's an application of the normal distribution. So what I'm going to do now is I'm going to solve this problem the way we did them back in chapter 5. So if it didn't say to use the normal to approximate the binomial problem, if it didn't say that, how could you have solved this problem? That's what I'm going to do next. All right, so I'm looking for the window I just had up here. There we go. All right, so I'm just going to get that example one more time. Okay, that didn't turn out very good. I have a black line on my screen. Okay, let me try that one more time. Do it a little bit slower this time. Okay, better. So we just have a new screen. It's the same problem. I just copied it so we have more space. All right, so if I had not told you to use the normal to approximate the binomial, then when you read this problem, and if you can identify this as a binomial, then you could just use the binomial method. So we said n was 40,000, p was 0.03, and I didn't leave enough room for x. That's always at the end, and sometimes there's just not enough room, so let me move it. So x was supposed to be 1,150 all the way to 40,000. Okay, so it's 1,150 and anything bigger than that. That's what at least means, at least 1,150. Okay, so if I was using the methods from our previous chapter, chapter 5, what command on the calculator would you use here? We had two to choose from. It was the binomial PDF and the binomial CDF. Okay, that's right, binomial CDF. Okay, so I'm going to use the binomial CDF. And when I enter my information, I have to enter the n first, so that's 40,000, and then our p. And then for x, I remember whatever we enter here at the end, it's going to calculate that value of x and everything to the left. But that's not what we want. We want 1,150 and everything to the right. So you kind of have to work your way around how that CDF works. Yeah, so this is the one where we find the probabilities of what we don't want. So 1,149 all the way to 0. So if you're looking at everything to the left, that's how the CDF works. If we calculate those, we could put 1,149, and that gives us what we do not want. But you already know the properties for a probability distribution. All the probabilities add up to 1. So when we find the probability of what we don't want, we can simply subtract that from 1. to get the probabilities of what we do want. So you're going to do 1 minus. So let's compare that answer to what we ended up with our approximation. Okay, so I see that I have 2 of you saying 0.9313. So if you didn't get that answer, let me know and I'll pull up the calculator. So is this 0.9313, is this the exact probability or is this one the approximation? What do you think? Right, this one is the exact probability. So just keeping in mind for those students who are watching the recording and are not in attendance right now, just in case you didn't get the same answer we have, let me just remind you of what you have to type in your calculator. You remember you have to do the 1 minus first on the home screen. Then you go to second vars. You go up to find binomial CDF, and there it is. Now, in the newer calculators, the information goes from top to bottom. So we have N, which I believe was 40,000. And our P was 0.03. And what we were putting in for X was 1,149. Because that calculates 1,149 and everything to the left, which is what we don't want. And the 1 minus was so that we get the other side, which is what we do want. I go over the word paste and I press enter. So notice that it just copied, it pasted what I had on the whiteboard. Press enter again, and that's how you end up getting the answer that we had. So it's 0.9313 compared to 0.9306, which was what we had with the approximation method. All right, so let me go back to the other one. So you can compare, and I'm attempting to use a highlighter here. Let's see if it works. So I'm highlighting. Nope, it didn't work. Let me try another color. I am circling the approximation, which is 0.9306. And here is our exact answer, which is 0.9313. All right, so there's 2 ways of solving these type of problems. And I can't emphasize enough, if it says to approximate using the binomial, you need to use this method with steps, where we had step 1, step 2. You have to use that method. Okay, so that pretty much sums up section 6.7. And so what I'm going to do is I'm going to go ahead and take you back to my stat lab, and we're going to open up one of those problems, and we're going to work on it. Now the only problem with this is that it's tiny when I look at it. So I'm going to try to see if I could. I know I could not in the past increase the font size. So let me take you to, but you know you can open it up on your own too. And so there's a question about, do you have to memorize the steps? No, you don't have to memorize the steps. Remember, as long as you can make a note on your, you know that on your midterm you're allowed to use the 1 page of notes. So, I mean, you could write it there if you need to. All right, now I put it as step 1, step 2, step 3, just to match it up to the notes. but you don't actually have to list it all out as long as everything's in order and I can see it. And that's fine. Okay. All right, so I'm back on my stat lab, and I was going to lecture to homework. So I'm going to go to homework. And under homework, I'm going to click on lecture 13. This is what you have to do in order to get credit for today's lecture. And I'm just going to open up one of the problems. They're both similar. So I just opened up one instead of two. Okay, and it doesn't matter. They're both very similar. Okay, so on this one, and I am going to make that, see, even when I make it bigger, it's not bigger. So I am trying something, and I'm zooming, but it does not affect the actual writing in here. Okay, so let me try something else. I'm just going to copy that. Over to the whiteboard. And I know it's really, really small on there, but you can match this up to number 1, okay? And if you open it up on your computer, you can kind of read through it as well. So I don't know where it looks better. Does it look better on the whiteboard, or does it look better when I was sharing the desktop? So that's the whiteboard. And that's the desktop. So does one look better than the other? Desktop or whiteboard? What do you think? Oh, the whiteboard looks better. Okay. All right. So then I'll just move on to the whiteboard, because the whiteboard looks really blurry to me. Now you know that at the very top where it says, at the very top, just above the whiteboard, it has fit page. Well, you can make it 150% or 100%, or you can just make it fit the page. Right, so you have control over that. Okay, well, you know it's number 1, so even if you can't really see it, just remember it's number 1. And I will read it so you can hear what I'm saying. Okay, so it says the probability of flu symptoms for a person not receiving any treatment is 0.045. So the probability is 0.045. In a clinical trial of a common drug used to lower cholesterol, 48 of 990 people treated experienced flu symptoms. So we have 48 of the 990 experienced flu symptoms. Okay. Assuming the drug has no effect on the likelihood of flu symptoms, estimate the probability that at least 48 people experienced flu symptoms. So the probability that at least 48 people experienced flu symptoms. That's what we're looking for. Okay, so I still have to identify an N. And here for X has to be 48 or anything above 48. So 48 and above. So N would have to be the larger number, right? So we have 48 and 990, so n must be 990. So what we have to do, let me change my colors here, is step 1 says we have to check n times p and n times q. So you want to make sure that that is satisfied. So what do you guys think? Is it satisfied or not? All right, only if it's satisfied can we continue. Okay, so we can continue. You might have some homework questions, and the reason I do this is, the reason I'm doing this is because in the homework questions, you might have a situation where you can't, it's not satisfied, where step 1 is not satisfied, where n times p is not greater than or equal to 5. So it's very important to be able to check it first. All right, so there's a question. It says, do we all have the same numbers of the problem? And you shouldn't have the same numbers, but some of you may, some of you may not. So it just depends. If you miss it and you do it again, you're going to get different numbers. So yeah, you shouldn't have the same numbers. All right, so the reason I wanted to do this is just because after the part where you have to enter your probability, you are asked more, you're asked more about it. You have a couple more questions to go through. Yeah, so we're all getting different, we all have different numbers in our word problem. All right, so the next part is that we have to find our mean and our standard deviation. We have to find the mean and the standard deviation. So the mean is n times p, and the standard deviation is the square root of n times p times q. So what do you guys get for the mean, and what do you get for the standard deviation? Okay, so that's the mean and the standard deviation. All right. Okay, so step 3, you are going to have to identify what your x is. So that's just your starting point. Where are you going to start when you're looking at your distribution? That's our step 3. And x is going to represent that strip. So any ideas on what x is going to be here? Okay, so x is, well, the question says, what's the probability that x is greater than or equal to 48? Because it says at least. What is the probability that they at least have 48 people who experience the flu? Yeah, so at least 48. So that's where you start. You start at 48. Now that's also right here in the question. Yes? Okay, so that's your starting point. So 48 is to the right of 44.5. 44.5 happens to be the mean, so I put it in the middle. Okay, now Jesse has our step 4 there. So you're going to add and subtract 0.5, right? So we have 47.5 and we have 48.5. Those are the markers for my strip. Those are the markers that I have for my strip. So the strip starts at 47.5 and it ends at 48.5. Okay, so again, it's hard to put all these in here, but I am drawing a line. 48.5. So there it is, 47.5 to 48.5. Now the question says we want the probability of at least 48 people experiencing flu symptoms. So when you see at least 48 people, are you shading to the right or are you shading to the left? To the right. And you are going to include the strip, right? Because it says at least 48, you're including the strip. So this kind of ended up being the same type of problem as the one I just did on the example. I was hoping to get a different one and it ended up being the same. So we keep looking at the at least, the wording where we have at least, but that's not the only wording you're going to run into. It could be at most, more than, less than, exactly. It's not just the at least wording that you're going to have there, right? And I think the second problem hopefully has something other than at least. So you are including the strip, definitely including the strip, because when you say at least 48, that means you're including 48. And then it's going to be everything to the right as well. So when you're deciding what to include, when you're calculating your z-score, you have to look at the part that's shaded, and you have to make sure that you're starting where you started shading. So you need to make sure that you are looking at the marker that begins that region where it's being shaded. And that's how you're going to determine what z equals. So z is equal to, and then you use that value of x. The marker starts on the left, so 47.5 is what we're using, minus the mean, and then you're dividing by the standard deviation. Don't forget the parentheses in the numerator. That is going to give you your z-score. Okay, now the z-score is important because remember that we do not have a standard normal distribution. We do not have a standard normal distribution. So I need the z-score that corresponds to that 47.5. And so what do you get for that z-score? Rounded it to 2. All right, so it looks like I have some agreement on 0.46. All right, so let's look up 0.46. in your table, now it's going to give us the area to the left, and so again we have to remember to subtract that. So when you look up 0.46 in table A2, you're going to get an area. And that area is the area to the left. So when you're looking at 0.46, yeah, did you guys get 0.6772? Okay, 0.6772. 0.6772. So if you look up the Z value of 0.46 on your standard normal tables, table A2, then you're going to get 0.6772. That's the area to the left. Of course, we need the area to the right. So in order to get the area, you have to do 1 minus. So it's going to be 1 minus 0.6772. So you guys agree on 0.3228? Okay, 0.3228. So I'm not done here. As you're going to see, I'm going to go back to the homework and I'm going to answer this question. So the probability that X is at least 48 is 0.3228. You have to tell me what this means. All right, so that's the part I wanted to get to. All right, so I'm going to enter here 0.3228, and when I enter 0.3228, let me show you what happens. Okay, so that's the answer we just got, the 0.3228. All right, so this is the part that I wanted to talk about. You have to interpret, you have to tell me what all that means, okay? So let me go ahead and take a snapshot of that, move it over. And I'll just have to read that for you. Okay, so our probability that X is at least 48 was equal to 0.3228. All right, so here's the whole problem again. It says the probability of flu symptoms for a person not receiving any treatment is 0.045. In a clinical trial of a common drug used to lower cholesterol, 48 out of 990 people treated experienced flu symptoms. Assuming the drug has no effect on the likelihood of flu symptoms. So we're assuming that the drug has no effect on whether or not you get the flu. What is the probability that at least 48 people experience flu symptoms? So when we're saying at least 48, we're trying to find the probability that 48 people or more experience flu-like symptoms. So 48 or more people experiencing flu-like symptoms gives us a probability of 0.3228. So what we have to determine is this probability unlikely? All right, that was from a long time ago, right? That unlikely is our probability unlikely. So if it's less than or equal to 0.05, it would be unlikely. And of course, here it's not. So we would say, no, It's not unlikely. So we would say it's not unlikely. Okay, we couldn't say that it's likely. We would not say it's likely. All we can say is that it's not unlikely because it's not less than 0.05. So what we look at here is, could this happen by chance? So in this case, the probability that x is greater than or equal to 48 is not an unlikely probability. So when you get to choose here, you want to make sure you choose the one that says that it's not unlikely. Okay, so the first one says it's highly unlikely, and that's not what we ended up with. And the last three say it's not unlikely. Okay, so it's one of the last three. Okay, so part B says the drug increases the likelihood of flu symptoms. Well, what we're saying here is that the probability of getting the flu is not unlikely, so it can happen. It's not a rare event, so it can happen. So the drug is not having any effect on this, or the drug is not having an effect on flu symptoms. All right, so the fact that more than 48 people are going to get the flu, that's not an unlikely event. If it was unlikely, if that was an unlikely event, then there's something going on with that drug. If it was lower than 0.05, then we would be concerned, because then the probability of that happening would be unlikely. We wouldn't expect it to happen. So if the probability is unlikely, then we would have to say that, you know, this drug is giving people like flu symptoms, or flu symptoms. All right, so it can't be that one. And then we have the drug increases the likelihood of, let's say, crossed out part B. And the next one says the drug increases the likelihood of flu symptoms because X, and we just said that's not unlikely. So this is highly unlikely, it's not highly unlikely. So you want to make sure you cross out everything that says that it's highly unlikely. And both A and C said highly unlikely. B is not going to be our answer because it says there that the drug increases the likelihood of flu symptoms, and that's not true, because we have a probability that's greater than 0.05. So it can't be that the drug is causing this. Okay, so the only option here is part D, which says the drug has no effect on the flu symptoms. The drug has no effect on the flu symptoms because the probability that 48 or more are going to get flu-like symptoms is not an unlikely event. It's not smaller than 0.05. So that's going to happen in the general population. That is going to happen. All right, so I just want you guys to be careful with the wording when you come to these type of problems. After you answer the question, you still have to describe what's happening. Okay, so we would expect in our general population that it's not unlikely to develop the flu. So the fact that this probability is not smaller than 0.05, we can't blame that drug for giving likelihood, for giving flu-like symptoms. So only if the probability of more than 48 getting the flu, only if it was 0.05 or less would we be concerned. If it was unlikely that more than that 48 people or more would get the flu, then we would be concerned that this drug is giving them flu-like symptoms. Okay, so in this case, the drug has no effect because this is greater than 0.05. So in a very similar way, you're going to go ahead and do this one. Now, oh my goodness, yes, finally it's a different inequality here. So the question here is estimate the probability that we have 102 or fewer cases. So now X is less than or equal to 102. All right, so finally it's a little bit different situation there. All right, so let me just write it out so that you see it. So it's the probability that X is less than or equal to 102. So when you get to that step, I'm not going to do this one, but when you get to the step where you have 102, and I guess I have to find what the mean is before I know where 102 is. At the strip, I'll just put the strip right here. The strip that you have, 101.5 is where it starts, and 102.5 is where it ends. So you have to decide whether or not you include the strip. The wording is 102 or fewer. So if it's 102 or fewer, you are including the strip because you're including 102. So in this situation, if it says 102 or fewer, which side do you shade? Do you shade to the left or do you shade to the right of the strip? If it says 102 or fewer, are you shading to the left or to the right? Okay, good. You're shading to the left. You're shading to the left. So when you go ahead and you use the Z formula for your Z-score, to find your Z-score, what you're entering for X is where that shading begins. What you're entering for X is where that shading begins. So it's everything to the left that's going to be shaded, right? So where does it begin? It begins at 102.5 because everything to the left is going to be shaded. I'm trying to shade everything to the left. So for X, we are going to be using 102.5 minus the mean divided by the standard deviation. So the reason I just went ahead and I jotted this down is just to show you that you have to pay attention to whether or not you include the strip, and then you have to know whether you're shading to the left or shading to the right of the strip. So whatever the scenario is, the X is going to be where the shading begins. The X is going to be where the shading begins. So it's either going to be the X minus 0.5 or the X plus 0.5, depending on where your shading begins. All right, so those are the two problems you'll have to do in order to get credit for today's lecture. And then before we finish today, I want to give you a task before we meet. I want to assign something before we meet for our next lecture. All right, so I'm going to take you back to my stat lab, and under announcements, I am going to go ahead and put more information here about the midterm. We're still in week 7, so by the end of this week, this is going to change. I'm waiting for today to be over because I still have the announcements here about there being a homework due today. So when you go to week 7, you still have something due today, so make sure that you get that done. Once today is over, you are going to see a change on my announcement. So that's where you're going to find information about the midterm. Okay? So what room we're meeting in is going to be on the announcements page. The time of your midterm is going to be on the announcement page. What you're allowed to use on your midterm, it's all going to be in this announcements page. Right, so look for that. All the information is going to be there. I also will have under discussions, I will also have a topic for midterm exam questions. I don't have it yet, but you'll see questions for midterm exam question or topic for your midterm exam questions. So you want to make sure you're looking there too, because you'll also have more information there. All right, so here's the other thing I want you to do. This evening or the end of this week or this weekend, I want you to go to announcements. You're going to scroll down to the very bottom. So when you scroll down to the very bottom, look at what I have here. At the very bottom, I haven't brought that to the top yet, but at the very bottom I have sample midterms. Please make sure that you've looked at these sample midterms before our next lecture, because I'm giving you the opportunity to look through these and ask me questions. So at our next lecture, I'm going to answer questions based on the sample midterms. There are a few on here. I don't want you to get help, I don't want you to do all of them. If you can just do midterm number 1, if you can at least do all of midterm number 1 for spring 2008, and then we'll go over questions on just this one. And that kind of will give us a little bit, it'll give us different questions to tackle, and you will see all the different questions that could possibly appear on your midterm. Now, I'm not limited to these questions. This is just a sample of questions that I asked in 2008. Your sample might be a little bit different. I mean, you definitely need to know everything that's on this midterm, but you need to make sure you also go through your homework. Look at all the different questions I asked you on the homework and on the quizzes. And then make sure that you've reviewed your notes from lecture. What's on this sample midterm is probably about 70%, maybe 75% of all the material you need to know. I couldn't possibly put every type of question on a midterm because there's just not enough time. So I have to select sample questions. But this is maybe about 70 to 75%. All right, so your homework before we meet for our next lecture is to work on midterm number 1. Work on midterm number 1. And then next week you're going to be studying for your midterm. You're going to be organizing your information. You're going to be, writing up your 1 page of notes. And when you feel like you're ready, when you feel like you've studied and you're ready to take that midterm, I want you to use midterm 2 for practice. Give yourself 2 hours, and you should be able to do midterm 2 in 2 hours or less. And then use that 1 page of notes that you're going to use during our midterm. Try to mimic that test situation where you're not getting any help. You're not getting any help. You're not looking at any other resource other than that 1 page of notes. And yes, that 1 page of notes can be back and front, typed or written. If you want to type it out or write it out, it's up to you. But it's just a regular page. It's it's a 8.5 by 11 page of paper. It's just a regular size page. So back and front is okay. So when you feel like you're ready to begin the midterm, take midterm 2 as a practice to see how well you do. Unfortunately, with my stat lab and the way the homeworks are set up, you have a lot of help. So everyone's getting 100% on the homework because you have a lot of tools there to help you through the problems. If you forget how to do something, you just click a button and it tells you how to do it. So everyone should be getting 100% on the homework if you've been putting in the time. But you're not going to have any help on the midterm exam. So you need to get yourself into a level where you feel comfortable tackling these problems without help. The quizzes are a good indicator because for the quizzes you don't get any help. Now if you've been getting help with the quizzes, then you've been defeating the purpose of quizzes, because you weren't supposed to be getting any help on the quizzes. It was all your own work. So the first score you ended up getting on a quiz, that's representative of how well you know the material. Of course, I give you a couple of tries, don't I, to improve your score? But that first score is the measure of how well you know the material. All right, so try to mimic that test situation where you have 2 hours and you are only able to use your tables with the Z-score tables and that 1 page of notes, and see how well you do. And then I have another midterm here for you to mimic that situation again. All right, so this is where you start to prepare yourself not only to understand the material, but understand it at a level where when all the problems are all mixed up, that you can figure out which chapter, which section they're coming from, and know which formula is the appropriate formula. Because if you can't get to that level, then the exam on campus is going to be very, very hard for you. All right? So your assignment is to work on midterm number 1. And I will take your questions. If there are no questions, those of you who attend the live lectures, if there are no questions, then I will continue with Chapter 7 material. Chapter 7 will not be on the midterm, but I will continue my lectures because I don't want to waste any time. Now, for those of you who do not get to attend live lectures, midterm number 2, I did all of those problems during a lecture. And so midterm number 2 has all the explanations in a lecture format. So if you get stuck, that's what you're looking at. All right, but I'm not going to just show up on Monday and just solve all the problems on midterm 1. I don't want to do that. That's your job, okay? I do have the key there so you can check your answers, and I will go over any problems that you were not able to, that you did not understand. Okay? All right, so you have a lot to keep you busy. So that is all that I have for you today. I will stay logged on if you have any other questions. I'm trying to think if I forgot anything, but I think I already did a lot of talking. So the question was, are the midterms that I have there, are they about the same length? Yes. So as far as the length is concerned, I keep the same length. So that is about the length that your midterm is going to be. And that is a 2-hour exam. So if you're taking 3 hours, then you're not going to finish it. So you want to make sure you practice, practice, practice until you're able to recall that information in the time that you have for the exam, 2 hours. And there's no Scantron for this exam. That was the other question. So no, you do not need a Scantron for this exam. In fact, all of the Chapter 6 questions require that you show work. And just like I've been doing them in class, on the midterm I'll be sure to tell you when it's okay to use a calculator and when it's not. If it says use the formula, show your work, then you have to use the formula, show your work. But if it doesn't say use the formula, show your work, then it's okay to use your calculator. But you still have to write the calculator commands. You either did a 1-var stats earlier in chapters 2 and 3. You did a binomial CDF or a binomial PDF. You write it down so I know how you gave me the answer. So to know how many questions will be on the midterm, that's what you're getting from the sample midterms. That's about the length of how many questions you'll see on your actual midterm. Okay? All right, so I will stop the recording, but those of you attending live, I'm still here if you have questions, but don't log off yet. I am printing the list. And again, I'm noticing that when you're logging in, some of you are still just typing in a first name. Remember, I don't know who you are if you do not type out a last name as well. So your screen name should be your first name and then your last name. Okay, all right, well have a great day, and I will talk to you next time.